right, so for number 33, it said you have S's between R and T. So there's R, there's T, there's S. And you're given RS is 2Z plus 6, ST 4Z minus 3, and the whole thing from here to here is 5Z plus 12. Now, I told you that I wanted you to do this, that I wanted you to say that RT is equal to RS plus ST. I want you to write the first step of the segment addition postulate every single time, and then I want you to substitute stuff in. 5Z plus 12 is equal to 2Z plus 6 plus 4Z minus 3. Now, the reason why I wanted to show you this problem is because sometimes, well, one, when you put and substitute in for RS and ST, I would always recommend putting in parentheses, whether you're adding or subtracting, because if you happen to be subtracting these two and that was minus something, sometimes the negative sign doesn't carry over to both things inside the parentheses. So by putting stuff in parentheses, if that was minus, then we know it would be minus 4Z, then minus a negative 3. Where one of the one of the most common errors is if it was this. And I know this is not the problem. If you don't write it like that, sometimes people just write it like this. And just put the minus sign in front of it. And then all of a sudden, what should it actually be? Negative 4Z plus 3. But a lot of people don't carry that negative sign over to the next term. So in order to avoid that, it's always good to put stuff in parentheses. Now, I learned this because I was extremely sloppy when it came to mathematics. As you can see, I have terrible, horrible handwriting. I heard that. Nothing. That's because you're blind. Now, when you're doing something like this, there's a different way that you can go about doing this. If you're comfortable just looking at it and saying, all right, that's 2Z, that's 4Z, I can add them together, we're good to go. I told you yesterday, I like to work vertically. I would take this, 2Z plus 6, 4Z minus 3, and I know I got to add them up. So I would take 6 plus a negative 3, so it's 6 minus 3, which is 3. 2Z plus 4Z is 6Z. I line them up by like terms. I get my answer without any problem whatsoever because my like terms are all lined up. Everything's in the right spot. Everything's good to go. Now I got my 5Z over here plus 12. And at this point, I'll say to myself, all right, I have 6 Z's over here, I have 5 Z's over here. I'll subtract 5Z from both sides. So I'll say negative 5Z is equal to negative 5Z. Because remember, I always use the whole idea that A equals B and C equals C. Then in this case, you'll get A plus C is equal to B plus C. I always add. So that's why I put a negative there and a negative there. I can add them up. Now, technically, yeah, subtracting, all that kind of fun stuff. Being technical, 5Z plus a negative 5Z is 0. There's your 12. 6Z minus 5Z, how many Z's do I got left? 1Z. 1 Z's. Plus 3. That was funny. That was funny. All right, now, I have 12 equals Z plus 3, but I don't want Z plus 3, I want Z. Subtract 3 from both sides, so minus 3 is equal to minus 3. That's a 9, that's a Z, that's a 0. We don't write it like this. We go Z equals 9, and we're good to go. So I wanted to show you that in the middle of the problem, when you're doing your work, there's nothing wrong with doing it like that. you don't always have to do everything in a horizontal line. If that confuses the heck out of you, put them into columns. Put them into columns of like terms. Columns of like terms work out really, 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 really nicely. Yes, sir?
No, we have to put the C into the RT as RS.
I can't even find the numbers. No, all it did, it asked to solve for the variable. So all it did, it just wanted to know what z was equal to. So, but if we wanted to, we knew RT was equal to 5z plus 12. If it asked us what RT was equal to, we'd say RT is equal to 5 times 9 plus 12. And so that's 45 plus 12. That's 57. So RT is equal to 57. So if always read to ask what it's asking for. For every single problem, check to see what it's asking for.